Chapter 10 is about inverse functions, exponential, and logarithmic functions. So let's first start out with finding the inverse of functions. So remember earlier when we first started learning about how to define a function, we started defining functions using relations. And a relation can be defined as a set of ordered pairs. We could make a table of values, right? I could put all these ordered pairs in a table of values if I wanted. I could have a graph, right? Something's a function if it passes the vertical line test. We'll go over that again. I could also define a relation as an equation, right? Here we have a line. All lines are functions. And the reason we were defining relation was in order to build up to defining what a function is. When I first started talking about functions, we talked about vending machines, right? When something functions, it works. How would our vending machine work? So a relation is any set of ordered pairs, but a function is a relation in which for each distinct value of the first component, there's exactly one value of the second component, i.e. each x has only one y. And that makes it a function. Remember when we were talking about our vending machine, we've got our buttons, right, that we can push, and we've got our snacks. And if I had, like the button A6, going to chips and apples, this vending machine would not function, right? If I pushed A6, what would I get out? Well, I don't know. The machine would break. It doesn't want to give you two snacks. So exactly one value, so each x has only one y value. It is okay for each y to have more than one x. Like if I have a snack machine and I just have it full of chips, so much so that I have a bunch of buttons like E7 and A4, all giving me out chips, that's still going to work. Because if I push E7, I know I'm getting chips. If I push A4, I know I'm getting chips. So it's okay for a y to have more than one x value, but each x needs only one y. This is not a function, and this is a function. And we talked about this earlier on in the text. Here's my lovely vending machine example. So the domain of a relation is the set of all possible values of the independent variable x. And the range of a relation is the set of all possible values of the dependent variable y. I know I've said this a million times, but I'd really like to mention it so we're all on the same page. So let's determine if these three relations are functions. So I like to do that by setting up a XY map, right? A drawing. So here I have 1 and 2, 4 and 5, and -1 and -2. Is this a function? Yes. Yes, it is. Let's take a look at our next example in green. So I've got G, our relation. I have for G, I have -3 goes to 5. If I plug -3 in, I get 5. -2 also goes to 5. That's okay, right? I can have two x's go to the same y. My vending machine would still work. I've got -1 going to 4 and 0 going to 1. So this is also a function. Last but not least, in orange, I bet you can guess what this one's going to be. So I've got my x's and my y's. I have -1 going to 0. -2 go to 2, and then I have -2 appear again and go to 1. Is this vending machine going to work? No, if I push -2, what do I get out? So this is not a function. Another way to test if the graph of an equation is a function is with the vertical line test. If every vertical line intersects the graph at no more than one point, the relation represents a function, right? that means for each, because here's my x-axis, right? All of these are x values. And if I intersect my graph only once, it has exactly one y value. A circle is not a function, right? If I have x is 2, in this case, 2 goes to 4 and negative 4. So this is not a function. When a function f of x is defined with an equation using x and y for the independent variables, x and y using x for the dependent, for the independent, and y for the dependent variables, we say y is a function of x because y depends on x. And in order to emphasize this notation, we have already been doing this, but it's just a refresher that we write y equals f of x because y and f of x are synonymous. F of x is just another name for y, and it tells us right away that what we're looking at is a function. And what we're working with is a function.